Welcome everybody to another lecture on our science and technology series. Today we are going to start with a very different topic and very interesting topic. This is IT, computer and robotics. In these set of lectures, we are going to study a lot of technology that is there in the world today. Also, we will be studying about technology that is upcoming because that is one of the favorite areas of UPSC. They tend to ask things that are coming in the future. So we'll be discussing about supercomputing, then quantum computing. We'll be discussing about artificial intelligence, robotics, 5G. We'll be discussing basics about lot of basic about robotics. Not very deep because not many questions come on this. So we'll be discussing a lot of things related to IT and all, big data also. So let's get started. To start with, we'll be going ahead with supercomputing. Now, supercomputer basically is a computer like your own. Like most probably, you are watching this on a computer. Like right now, I'm making this on my laptop. This lecture I'm making on my laptop. So when a lot of computers are there in one setup, basically that is supercomputer. But there are some technical things which we need to understand. So if you look at the photo, you can see there are many cupboards. Now in such cupboard, there are some lights, as you can see. All right, just a second, let me change the ink color. So this is a slab. Okay, sorry, white color is not visible. Okay, anyways, so this one thing, this whole thing, this one cupboard is basically a slab or a cupboard basically. All right, so these things inside, this is one unit, this is second unit, this is third, this is fourth, this is fifth. So this is like one computer, but this is very powerful. It has a lot of RAM size, it has a big CPU, it has a lot of storage area, which is more than your usual computer. So basically this thing, this one slab is a computer. And when all of these are combined, this is called as one supercomputer. So this is just how you can relate with your normal computer. Like if you want to understand supercomputer, you can understand in this way, that a lot of computers combined in an array. In an array, that means they are combined together, they work together for one goal. So basically, like your computer works for one goal at a time. Of course, technically it can work for many goals at a time, but still right now, like I'm recording on this laptop. So such computers are used for big things like weather forecasting and population management and so on. Now, the technical definition. Basically, like I said, supercomputer is a computer with high level computational capacity compared to a general purpose computer. Very simple. So you have to understand it with respect to a general computer. So they are designed to deliver facility or to provide service for something particular, and they need a lot of performance also, like weather forecasting. We'll see the application. All right, now how to measure their speed? It's in floating point operations per second. This is the basically like there is kilometer per hour, right? Speed measurement. So their speed is measured in flops, FLOPS, floating point operations per second. Now see, in 2020, IBM helps launch the COVID-19 High Performance Computing Consortium to research the COVID-19 virus and its potential cures. So to solve the COVID-19 problem also, supercomputer was used. Supercomputer was used. Now, this high performance computing consortium, this is basically a supercomputer. HPC is a supercomputer. In India also there is a HPC like this. To develop supercomputers in India at large scale, the government of India launched a national supercomputing mission. Now this mission was launched in 2015, and it envisages, and basically it wants to empower our national academic institutions and research institutions by installing a supercomputer grid, which will have 70 high performance computing facilities. Basically 70 supercomputers will be there in different research facilities, and they will be joined with a network. What is the objective of this mission? To make India one of the world leaders in supercomputing, obviously, to attain global competitiveness and ensure self-reliance in the strategic area of supercomputing. So there is nothing to explain in this, hence I have just read them. So basically in these objectives, this national mission wants to enhance India's capability so that we can solve the issues that we are facing, like weather problems, like food security problems, like diseases, big diseases, just for an example. And also to become globally competitive. That means we are self-sufficient also, and we can compete with the world also. That means we can export things. Like right now, a few months ago, 1 or 2 months ago, COVID vaccine was given to many countries. Similarly, one stage it is envisaged that we would be able to outsource, or basically put our supercomputers on rent for other countries to solve their problems, because not everybody can make these computers. Even in India right now, there are no indigenously built supercomputers. All the supercomputers have been imported and then assembled in India. But this mission wants to create supercomputers from scratch in India, like developing uh, processors, microprocessors. All right. So one microprocessor is one of the main issues which are not manufactured in India at that level. So the government is working on that. What are the features of this mission? This will be basically implemented jointly by Department of Science and Technology and Department of Electronics and Information Technology with CDAC and IISC. We'll study about CDAC later. CDAC basically is the organization which makes supercomputers in India. Now, like I said, they will be creating 70 high performance computing facilities. Now, these will be linked by a National Knowledge Network, NKN. Right? Now, these grids will be connected with National Knowledge Network. Also, to train the Indian people, there is envisaged that a special supercomputer will be created known as Param Shavak. Alright, we'll discuss that later on. Now, in India, there are a lot of supercomputers, and fastest one is right now Param Siddhi AI. Alright, other computers are Pratyush and Mihir. Now, this is a high performing supercomputer. These are two computers which are linked together and they function at a very high speed together. Param Shakti is there, Rudra is there, Param Ambar is there, Param Brahma is there, Param Shivai, Param Yukti. So a lot of computers are there. I have just listed the top 8. Alright. So this is how it looks. Like Param Shivai looks like this. It has cabinets, and then there are small slots in which the CPU sits. Now, what are the applications? Applications are weather forecasting, scientific research, data mining, weather forecasting like monsoon, weather prediction. The path is predicted of a cyclone or a typhoon, right? All those, or tornadoes, all that is done with the help of supercomputer only. Normal computers cannot process that much data. Then scientific research like COVID-19 research. I just gave you an example. Then God particle research, that was all done with the help of supercomputers only. Large Hadron Collider is there, no? So that is the calculation or the data that comes out of the collider. It is calculated or made sense by a supercomputer only. Then data mining, because lot of businesses collect data nowadays, and to make sense of it all, we need supercomputers because normal computers cannot do this. Also, as we will read, artificial intelligence also needs a lot of data to learn something. So all that data is kept at a place and given properly to the artificial engine by supercomputers. So a lot of data is being generated in the future and also in present time. Lot of what I meant to say was lot of data is being generated right now, and in the future more data will be generated. So normal computers will not be able to handle such amount of data. What are the challenges of supercomputing in India? Like, what are the issues we face? First of all, funding. Actually, as a developing country, there are a lot of things in which funding will never be appropriate because, again, like I said, developing country, limited source of funds. So, due to which some issues are there, and supercomputing has developed late in India. But again, with the 2015 mission, which we just discussed, lot of attention is being paid. Limited hardware development. Briefly, I have mentioned that India lacks in microprocessor building. So, and also in developing other things of top quality, which can be used in supercomputers. So, we have limited hardware development in our country, due to which indigenous supercomputers are not there. Then brain drain is there. Large multinational companies are taking away quality people from India, like Google or other like IBM, Microsoft. So this is not, there is nothing wrong in this, but yes, India is being at a loss, right? Good researchers are going to companies which can pay more, and of course, this is capitalism, and this will happen. Limited R&D capability because of funding, because people are not there, because people are not interested also, right? So limited R&D capability is one of the main concerns, which is basically a main challenge to a uh, which is a main challenge basically, or a hindrance in creating a supercomputing environment in India. So what is the way forward? What can we do? See, Indians have good software skills, right? All they need is proper environment to flourish, and of course, that includes financial remuneration. Also, policies should be there of IPR, right? We have talked about IPR. So India needs to focus on, first is this, like we need to stop the brain drain. Second, we need to focus on new approaches. Like supercomputing's time has gone now. Of course, we should develop it, but the research that can be done, it's done. I mean, you can't make any uh, how should I tell? Like research in supercomputers will not yield a lot of profit right now, because all that you can do is increase their speed, that's all. But what if you can get new technology, and that new technology is quantum computing. Quantum computing, optical computing, we should focus on these things now. All right, of course, then funding is needed. So these are three way forwards. Now let's come to a project which is called as Top 500 project. It ranks top 500 supercomputers in the world. It does so every 6 months, and this was started in 1993, and updated list is given out twice a year. So the first one in the latest report is supercomputer Fugaku. It is from Japan. Then supercomputer Summit. It was developed by IBM in United States. Then Sierra. It is again a United States IBM built supercomputer. I think fourth one is Chinese built. I don't have the name right now, but I faintly remember reading it. Indian ranks are 62 and 77. This is pretty good. Param Siddhi AI, it is the first one. It is developed by ATOS and CDAC. Pratyush is there. All right. Its nickname is Cray XC40. It is it is used by Indian Institute of Tropical Meteorology. This is for weather forecasting. And the first one is used by CDAC. All right. So these are the two in the top 500 list. So what is CDAC? I have mentioned this before. See, it's the premier research and development institution of Ministry of Electronics and IT. It carries out research and development in IT, electronics, and relevant areas. So this institution, just a brief history about this. It was developed in or started in 1988 for the sole reason for CDAC was to create supercomputers in India. And Param 8000 was the first supercomputer which was built by CDAC. Alright. Now let us talk about one application called as spiking neural network architecture. So this is world's largest largest electronic brain. Alright, it works like a supercomputer and it was turned on recently for the first time. It basically works like human brain but with the help of lot of electronic boards, circuit boards which are connected to each other. But again, its maximum speed is still less than 1% of human brain. So again, machines are quite far from this. But of course, supercomputers work faster than any human brain. But this is something else. It because it mimics human brain. So that is different from a normal computer because things are interconnected. Like a human brain can process smell, noise, like this. So this computer also can see or detect different things. See, read this side. Unlike traditional computer, it does not communicate by sending large amount of information. Instead, it mimics the parallel communication architecture of the human brain, in which lot of information is simultaneously processed and sent to different destination. It is funded by Human Brain Project of the EU. So do remember that it is not by IBM or something. This thing can be asked in prelims directly. All right. Finally, Param Shavak. We discussed about this. Basically, it's a supercomputing solution in a box. This will be used to teach humans in India about supercomputing. So basically, HPC, high powered computing, aware workforce or skilled workforce. So you have to train people somewhere. You can't train them at actual supercomputer. So Param Shamak will be a supercomputing solution in a box in which it will be used to teach people at the grassroots level. It will be used in universities where they can utilize supercomputing power at a cheaper rate. So again, this will help universities get academically advanced. Okay, this will also help administrators, right? Now let's come to quantum computing. Now what is it? Now see, before we start this topic, you need to understand one little background, that the normal computers, they work based on zeros and ones. This is called a bit. All right, one single is called bit and these two things are called bits. So either it will be 0 or 1. So like right now we see things in terms of what is on the screen, but the computer understands and translates this all these letters like it is written WHAT, right? What is written? Computer will convert everything into zeros and ones, right? So this is called a conventional computer. So a conventional computer, like the computers that we are using, they use 0 and 1 to understand everything. And secondly, at a time only they can understand 0 or 1. They cannot understand both the things at the same time. Like electricity switch can be on or off. It cannot be both. So this is these two things you need to remember before we can move forward. Now in quantum computing, what happens is quantum computer also have these bits, but in quantum computer the bit can be 1 and 0 at the same time. In normal computer it can either be 0 or 1, but in the quantum computer it can be 0 and 1 together at the same time. This is called quantum superposition. And quantum bits are called qubits. They are called what? Qubits. So they exist in superposition, because of which the computer can obviously work fast and very much faster than the conventional computer. All right, that is why you must have heard the term binary. All right, 0 and 1. This is this is where it comes from, 0 and 1, from the conventional computer. So quantum computers are those computers which take the advantage of this strange ability of subatomic particles to exist in more than one state at any time. Subatomic particles like neutron, electron, proton, and so on. So, with the help of quantum superposition, now this is superposition. What is superposition? A subatomic particle being 0 and 1 simultaneously, that is at the same time. Now you don't need to understand how it works, you just need to know that this thing exists. Because of superposition, a quantum computer can act like many conventional computers. Obviously, it's like having two hands. A conventional computer has, oh, sorry, not even two hands. A conventional computer has one hand, but a quantum computer has two hands. So obviously, quantum computer will work faster, right? So because of this thing, because of this feature, basically, things can be calculated very quickly and faster, basically quickly than classical computers, and in a much less power. Sorry for that. Basically, they can be solved faster and cheaper in terms of power. Okay, so this is the basic behind how it works. Now there is another term with the superposition, which is entanglement. All right, entanglement means the qubits, like let's say these are qubits and these are another qubits, set of qubits. They are entangled with each other. All right. So this means that this qubit and this qubit will work together to solve a problem. Now it doesn't matter if this qubit is in the same room or even in different computer. If these are entangled with each other, they will work together to reach the goal. So with these two principles of entanglement and superposition, qubits can act like very sophisticated switches. Like I just told you, na, normal switch can be on or off. Oh, sorry, off or on, whatever. Right? But switches made from qubits will be very sophisticated. They can be on and off at the same time. So this will make the quantum computer work in a very efficient way. Right? Okay, so this is the thing. Please remember this. These three things: qubits, entanglement, and superposition. Now, why are we studying about it? Because rapid development is going on in this field. When this technology comes, it will disrupt a lot of sectors. It will disrupt the way of life. And if India utilizes this quantum computing arena as fast as it can become a global leader, or at least faster than other countries. Basically, India needs to utilize quantum computing revolution before other countries so as to become a global leader in it. Like right now, we are sort of a global leader in satellite launching, and that is because of the 30 years, 40 years that it has taken to us to develop a technology all alone. All right. So major technology disruption will come. That means it will affect every area of our life. Let's come to a term, quantum supremacy. Now, this is a situation in which a quantum computer can solve something or some calculation which a normal computer cannot solve in a reasonable time. Now, Google has officially announced that it has achieved quantum supremacy, right? In this, basically, if you see this last three lines from the first point, that it can solve a problem that no classical computer can solve in any feasible amount of time. That means, let's say 50 years or 100 years. But Google solved something. Google says that its 54 qubit processor was able to perform a calculation in 200 seconds that would have taken the world's fastest supercomputer 10,000 years. My God. So a supercomputer would have taken 10,000 years to solve it, and the 54 qubit processor was able to solve it in 200 seconds. So this is quantum supremacy. What are the applications of quantum technology? Now this is very interesting because it will help in secure communication. China is researching a lot in this, and they have also demonstrated that you can have quantum communication between satellites and terrestrial stations. This will be very important because whosoever has proper quantum communications, nobody will be able to hack them. Research, it will help in research. As I told you, such big computers are used for calculation. So similarly, this quantum technology will be used for calculating a lot of things like studying black holes, studying gravity. All right. Then Genome India project is going on. If we have a quantum initiative, it will help a lot because new things can be generated, which obviously, like I gave you the example of quantum supremacy. A supercomputer will take 10,000 years to do something which was done by the processor in 200 milliseconds. Sorry, it's 200 seconds. Disaster management, predicting earthquakes, predicting drought, predicting tsunamis, and collecting data, which will basically studying the impact of all these disasters on agriculture, food technology, farmland wastage. So lot of application is there. That is why I said na, it will affect every area of your life. Then pharmaceutical, because India has a large population, India is also a leader in vaccine development. The not the original vaccine development, but again the generic. So if our industry can utilize such quantum technology to research medicines, to track behavior of medicine in cells and so on, and also even to do a research. So all these things will be helped by quantum technology. Finally, augmenting Industrial Revolution 4.0. We will study briefly about Industrial Revolution 4.0. So in this, basically everything is included. AI, I am talking about Industrial Revolution 4.0. In this, everything is included, like AI, like big data, like machine learning, all right, Internet of Things, also quantum technology. So all these things will revolutionize the way industry is working. All right, and it will help us solve many issues, but again it will create an issue of job, which we'll discuss. But for now, there are a lot of positive effects. Now let us see what are the efforts which have been taken around the world in quantum computing field. Of course, China and USA are leading it. China has the highest number of patents filed in this field. In 2018, US gave $1.2 billion for quantum research. India is also not far behind. India has started a national mission on quantum technologies and applications. Right now, there are no quantum computers in India, but in the Union Budget 2020, it was announced that 8,000 crores will be invested in the national mission on quantum technology and its application. All right. What more? In terms of R&D, sadly, India lags behind other countries. In the last 10 years, there have been less than 100 international publications from India on quantum computing. So what are the steps taken by Government of India? The government has kickstarted a research project which is called QUST, Quantum Enabled Science and Technology. But again, not much significant progress has been made until the NMQTA, which was just launched. Okay, we'll study about this. ISRO, in collaboration with Raman Research Institute, they have started a project called as QUEST, Quantum Experiments Using Satellite Technology. So they are experimenting in satellite technology by basically, you can understand it by taking an example of communication, secure communication. So let's study about the National Mission on Quantum Technology and Applications, NMQTA. Ministry will be Department of Science and Technology. Budget is around 8,000 crores. Then focus will be on science, basically, and developing useful products which will help in national growth. All right, it will also help startups to create those products. Application will be a lot, quite a lot, like aerospace, engineering, cybersecurity, health, agriculture, education, development of skilled labor, right? Significance, I think you can understand. A boost in quantum technology will help India compete with USA and China. As simple as that. And also it will boost our economic growth. All right. So of course, these two are big enough reason to invest in quantum technology. Also, one of the most important part of quantum technology application will be secure communication. Secure communication, especially the military one and the satellite communication. Because if some people or if some countries have the quantum technology, they can easily hack the normal communication or normal communication secured by normal computers. Okay? What are the challenges in quantum computing field? Basically, you cannot harness the superposition for a lot of time in a controlled manner. It is very fragile. The qubits are very fragile and they lose their feature of quantumness if not controlled properly. Hence, a very specific temperature is required, and only few materials can achieve or basically be used to develop quantum computer. Then, of course, the challenge is of creating the algorithm for quantum computers, basically the software part. Similarly, these projects will place demand on the classical hardware as well as software, because such computers, quantum computers, might replace these computers. So, lot of jobs will again have to get converted into quantum computing jobs. Lot of companies will shut down and so on. Then security infrastructure would never be same. As I told you, anyone with quantum technology can hack any normal communication technology. Warfare will change. People will start hacking your systems rather than directly attacking you. So India has to quickly adapt and create such systems in which we can use quantum computing. All right. Here I would like to mention a word, RSA. RSA encryption. This is used to encrypt the communication. It's an algorithm. All right. So if RSA is asked in exam, it is type of a algorithm. So what is the way forward? See, the government needs to partner with institutions like private institutions which do research and the scientific community, so that we can come out with our own quantum technology as soon as possible. Then private funding by CSR, by philanthropy, should play a big role in researching. Because why am I saying philanthropy? Because such technologies take a lot of years to fructify. That means it will take at least 3 to 5 years for anything to come out. Like a lot of money will go on research and then something will come out of the research. So this is the one of the most effective ways, because China and Singapore are already using this method. So what they are doing is they are using private funds like from CSR and from philanthropy, and trying to attract intelligent people from all over the world into their country and asking them to do the research. So government of India needs to do something like this. All right. Now let's move on to one of the very interesting topics called blockchain. We are not going to study it in a lot of depth because that is not what is required, but we will be touching a lot of related areas. All right. So what is a blockchain? Let us see the definition. Or before even talking about blockchain, let me tell you how things are done right now. So whenever you do a transaction, it is placed in a central database. For example, you are basically buying a land, let's say, right? So it will go and get stored. The data will go and get stored. Or let's say the proof of transaction will get stored into a central database, which will be basically government database. All right, it will be central. Okay, be careful and remember this word, central. But in blockchain, what will happen is the transaction will get stored in 2 3 computers, not in one computer or in many computers. So if no one can steal that data. Right now you must have heard from many news articles that a company data was hacked, है ना? So that is dangerous because we lose our data. Now if that data is stored in 2 3 places, Nobody can hack 2 3 places at once. Also, never ever one thing is stored fully at one place in blockchain. In blockchain, things are stored distributively. That means never, basically opposite of centralization. All right, like Panchayati Raj, right? It's a decentralized, uh, basically you can say decentralized way of governance. Similarly, blockchain is decentralized way of storing data. So let's now try to understand the technical definition. Let me read it for your benefit. Blockchain technology is a structure that stores transactional records. I said not transaction, you are doing a transaction. So basically if you do a land transaction, that will be stored in a blockchain. So that will be a block. The transaction that you do will be a block. Now it will be stored in several databases. Now this is called chain. The database in which it is stored is called chain. The transaction itself is called as a block, and it is connected by peer-to-peer nodes. This storage is referred to as digital ledger. So I know lot of new words. Don't worry, I'll explain you all this via beautiful diagram. Now, three key principles of blockchain technologies are transparency, decentralization, accountability. Transparency means everybody can see the transaction. Decentralization means opposite of centralization. Whatever you store, it is stored in many computers. Accountability, basically, if you are doing something wrong, you will be held accountable. That like this. So blockchain is basically a network of computers which are called nodes, which have the same history of transaction. So everything is stored on every computer. All right. So there will not be one database which has all the information. Now the information will be spread across lot of computers. So your information is basically safe from hacking, because even if somebody hacks one computer, the data will be copied from the safe computer to the hacked computer later on. So with this technology, you can trade with anyone around the world without knowing anyone personally, because right now blockchain is used for cryptocurrency. So many people trade Bitcoin, but they don't know each other. This has been used for, as you can imagine, by nefarious people for black market transaction, for terrorist organizations. All right. So let me rewind. Block is the transaction. It's one record. When it is completed, when the transaction is completed, it is added to the chain. So block chain. Now let me give you another example. For example, if you want to sell your smartphone, right now you have to go to Amazon, which will be basically an intermediary between you and the seller. Amazon does not sell anything directly. It has sellers on its website. Now the payment might be processed by a bank, and you also pay some transaction fee on for that. Now because of blockchain, you will be able to sell your smartphone directly to that person without actually involving Amazon or eBay or any other bank also. All right, so this is very basic example of blockchain. Now let us see how it works, which is much more interesting. So this is the record. This white cube is the record. This is the block, a bundle of records. This is the block. Now this block sits over here. All right, and this is the chain. This whole thing is a chain. Okay, all the blocks linked together is the chain. A bundle of record is the block where your transaction sits over there. Okay. So records are bundled together into blocks and added to the chain one after another like this. So set of transaction or record is a block, then small block, all right, and many of the lot of blocks make up the chain. So this is the record, this is the transaction record. For example, Mr. Rajesh is selling, let's say, two of his mobile to Mr. Prakash. Then the record will have all the details, all right, and it will have a digital signature from everybody. Just an example, like anybody is selling something, so all the details will be stored in this record. Now record is accepted. This is the step 2. The record here, the record will be checked by the network, and the network is basically collection of computers, and these computers are known as nodes. Now these computers will check the record to make sure it is valid. So basically the network will check. Now this is the step 3. Here that record which is accepted is added to the block. Okay. So the block of the record is ready to be added to the chain. And then here if you see below, when it is added, it becomes part of the chain. So the block is added to the blockchain. Okay. Now how there is one thing which is called hash code. Now this one block has the hash code of all the blocks that are around it, so that it will, whenever it is placed in the chain, it has the hash code basically, which is you can say it is an identification code basically. So this every block has the hash code of every other block around it, and then it knows that I was sitting here. So if a block gets corrupted, this is how you come to know. If the hash changes, you know the thing has been corrupted. So how does it work? First, transaction is requested. Then a block that represents the transaction is created. Block is sent to block is sent to every node in the network. The network checks it. Nodes validate the transaction. Nodes receive a reward for the proof of work. Basically, they get some proof that yes, transaction is done. Then the block is added to the existing blockchain. The transaction is complete. So again, this is quite simple. Basically, transaction, basically normal transaction. Only difference is it is happening all online, and there is no in between. There is no bank, there is no Amazon, nothing. You can directly sell your phone to someone and they can pay you directly using blockchain transactions. One interesting thing, role of blockchain in fighting COVID-19. So how has blockchain helped in coronavirus? In tracking. How? Basically all the data that was being generated, right? That was that was basically reported in one typical design. Or basically, if you did not report the data in a particular format, it would get rejected. Then donation tracking. Basically, whoever donated it, the block would have all the information: when, where, donation volume, and receivers. So basically, you would not need anybody to track it. A block, when created, gets automatically tracked. A record is verified by every node, right? So it's a very different way of working of things. See, everybody will verify the transaction. Right now, Amazon will verify your transaction, but in blockchain, the nodes verify your transaction. Then it also helped in day-to-day operations. How? Basically, new networks were created, due to which new services were given. Customer services were given, and there was no intermediary. You could just dial a network, and then whoever was free will connect with you. User privacy, basically all the patient symptoms, everything was secured with the way of blockchain. Now all of these things is encrypted. It is not something which is readable by anybody. Medical supply chain, this is hypothesized, hypothetical, that technology can help in supply chain companies in attaining a fast flow of supply by tracking the flow from origin to destination in a reliable manner. So let's say a medicine starts from Dubai and it's coming to Mumbai. So everything, maybe it is coming by ship, maybe it is coming by aeroplane, mostly it is coming by aeroplane. So if it is something non-essential, then it would be coming by ship. But since it is essential, it will be coming by aeroplane. So if some medicine is coming from Dubai, then everything that was tracked, it would be saved on a block. Not use. So basically you don't need anybody else. That's my point. If you use blockchain, you will not need third party to record anything. That's the benefit. What are cryptocurrencies? Of course, if we are discussing about blockchain, we have to study about cryptocurrencies. They are basically digital assets that work as a medium of exchange, like money. Simple. And they are stored in a digital format. They don't have a physical mode. They all exist in a way of digital currency. So they are stored in the form of information on servers. But how do they protect themselves? They use cryptography. That means, again, encryption and decryption. So if you are selling somebody or if you are paying by Bitcoin, those records are saved on blockchain by high level of cryptography. All right. Now, cryptography or cryptocurrencies, these are becoming famous because there is no central authority that will control. And one of the most famous one is Bitcoin. And Bitcoin was developed with the help of blockchain technology. Now, cryptocurrency is basically a medium of exchange. All right, just like money, it's digital money. You pay for things with cryptocurrency. Only point is it is not backed up by any central government or central bank. It has its own value. Basically, people give it the value. Only 21 million bitcoins will be there. So they are being mined right now. I think only 2 million are left or something. So this is not controlled by any central bank. What about India and cryptocurrency? India has around 75 lakh cryptocurrency investors who have around 10,000 crore invested in bitcoins and other such currencies. The prices of Bitcoin has surged 900% courtesy of the worldwide boom. All right, we don't need to know the value. It will change by the time exam comes. Finance Minister Nirmala Sitharaman has said that center will take a calibrated approach and leave a window open for experiments with blockchain technology. So central government or basically any government and or many governments and many central banks, they are against the digital currency, but they are not against blockchain technology. Everybody understands the benefit of blockchain technology. Especially blockchain technology will be good for India in terms of one thing, which is land records. So right now land records are obviously not digital. So blockchain technology will help in creating cheap digital land records. All right. Now there is one thing which I want to discuss, blockchain bill of rights. This is a term given by World Economic Forum. Point is, in the last few years, we have seen that whenever new technology comes, the user is the least benefited. The companies which are selling the service gets more benefit out of it. Take example of Facebook, right? Twitter. All these companies are benefiting more than the user. Users are being manipulated. है ना? So all these things point to an issue that people should have the right. So although basically there is a lot of promise from blockchain, but lot of thing will depend on implementation. So leaders in the blockchain space, they have told that we need to have blockchain bill of rights, basically rights of user who are affected by blockchain technology. So in this, the discussion which was there, in this they have said that we need to have baseline, that all the developers, corporates and government will ensure these baseline rights to every user while you developing blockchain applications. So these rights or this baseline has 16 principles which aim to protect the rights of users so that everyone can benefit, not just the companies but the users also. What are the challenges to blockchain technology? Basically, there is no confidence because it's an innovation. Anything new that comes up is always a little like people can't trust it blindly, right? Then high cost is there, complexity of blockchain is very high, people are not able to understand how it works. Even the government, people who are in government, even the everybody, like sorry, not everybody, but many people who are not from technological background, they are having difficulty understanding this because blockchain is totally new way of working things. Totally new. It changes how things work. All right. Many people in private sector also don't have any knowledge about blockchain. Then there is no standards. Like since it's a very fast developing technology, there are no standards. Like you have to ensure this much proper code and all that. No, there is nothing. There is no guideline. Nobody knows what to do. Then there is lack of regulation from the government side because, as I said, this is a transformative technology. This is a new technology which is coming up right now. And because of the lack of regulation, Supreme Court has ruled against a decision imposed by Central Bank of India nearly 2 years ago that stopped crypto trading. So nobody knows, right? After RBI must have taken some decision by thinking something. I'm not saying they were wrong, but again, after 2 years, the technology changed so much and it has entered our life so much that Supreme Court overruled. So since there is no regulation, such things will keep happening. Data regulation is not proper in many countries because of laws. So will matlab, people will lose some of their data before some laws come up. Lack of blockchain talent, of course, new technology, not many people know how to work it. 50% attack, basically this is a new term. It means basically the users or a group who wants to take control more than 50% of the network's mining power. This enables them to recreate the blockchain, thereby altering the previous transaction. Now, what is this? See, the let's take an example of Bitcoin. So Bitcoin is mined, mined. It is mined by computers because it is spread in the internet. There are 21 million Bitcoins in the internet. So whosoever can mine it can keep it, and mining it becoming difficult day by day. So here what will happen is, like I told you, there are nodes in a network. One node is one computer. So if some company becomes big enough, all right, huge company, which can purchase 51% of the nodes in the network. So basically it will own the network and then it can change any transaction it wants. That's it. So if question comes that 50%, 51% attack is related to what? Blockchain, right? So answer is blockchain. They can insert something else in it. It can become hostile takeover of a PSU or something like this. So this term is important. So let's see finally the government steps, especially by Niti Aayog. Niti Aayog has released a recommendation to establish India as a vibrant blockchain ecosystem. Now, in that, they have told that you need to create an India chain, right? This is basically creation of national infrastructure for deployment of blockchain with the inbuilt Indian platforms and built for India basically. Then Niti Aayog has said we have to develop India as a blockchain hub by promoting research and development. Procurement process of government should be changed to adopt blockchain solutions, basically land records and financial records. These can use blockchain properly. Then cryptocurrency for India, stable coin for Indian rupee for seamless exchange for blockchain solutions. This may be in conjunction with the need for reevaluating cryptocurrencies. Basically, Niti Aayog is saying that you need to develop a cryptocurrency also, but with, of course, regulated by the government. All right. So in the end, I would like to tell you that blockchain is likely to have a significant impact in creating our governance system in the future. So India needs to create such enabling legislations that can help in growth of the technology and in the end ensure that it works for India. All right, the technology works for India. Right. One of the best benefits will be corruption, or basically reduction in corruption, because this is a first-hand experience that after digitization, a lot of avenues for retail corruption have decreased. So digitization will be good for India. Now let's come to some terms like cyber physical systems. So what is the cyber physical system? See the name, cyber and physical system. That means basically whatever system is created, it will go out and work as a computer. So example is smart grid. That means you are combining computer plus you are combining something physical and they will work together. Similarly, smart transportation like driverless metro that is going on in Delhi. It was started recently, I think 3-4 months ago, or maybe in 2020 it was started. That I know. So, what about that? So that is also a cyber physical system in which computer is driving the metro and it is driving a physical thing. Then cloud infrastructure, physical thing because cloud infrastructure has hard disk in it, so that thing is controlled by software. So cyber physical system. Smart cities will have a lot of such infrastructure. So just understand it in this way. There will be something software based and physical based, they are combined. Done. Don't try to mug its technical information or technical definition. Another term for cyber physical system is basically Industry 4.0. Industry 4.0, which refers to basically fourth industrial revolution. Okay. More examples. In agriculture, cyber physical system can help reduce pesticide by identifying and delivering where it is needed. So you can have a sensor. How will it identify? Sensor. All right. Now this sensor will give information to the system, which will be the IT system. Now this is a physical sensor and this is the cyber part. And then according to that information, pesticide will be released. So this is how cyber physical system will work. It can improve the health and well-being of livestock also. By you can have a monitor on them, you can have a tag, right, which will, or sensor basically on their legs, on their tail, which will help analyze the health of the animal. One of the most important example that I can give you of cyber physical system, in South Korea, the atomic chemical power plant, the control of that power plant is fully computerized in South Korea. So that is one of the best example of cyber physical system. It is controlling something physical, but human is not controlling, software is controlling. And if you haven't heard about this, Internet of Things, we'll study briefly about it. So IoT are cyber physical systems only. And when I say briefly, we will study enough about UPSC. We will not be going into technological depth. All right. Where it can be used? In smart city, agriculture, infrastructure, internal and external security, healthcare, transportation, energy. All right. We have discussed a lot of examples on this. Basically, physical system run by something software based. Let me give an example. In energy, lot of times solar energy is not all the time available. Wind energy is also not all the time available. So we will have sensors which will store the energy whenever this energy is generated and basically give that energy in a proper load to the grid. Now for this to understand, you need to understand how grid works. So in the normal grid, it needs a proper flow of electricity. If there is too much up down, the grid will fail or it will be under pressure. So one thing is one problem that is there is to integrate the renewable energy grid with the non-renewable energy grid. All right. Now there is a national mission on cyber physical systems because even Government of India is very much aware of benefits. So national mission on interdisciplinary cyber physical systems under Department of Science and Technology. What are the focus areas? Technology, it will be developed obviously We will develop new cyber physical systems. Skill development, it will always be there. Innovation, entrepreneurship, startup, again, it has become a pet project of the government, and rightly so. International collaborations. So again, this this thing is a framework. If government asks you that we want you to develop a scheme, so in a technology, just write these 4 points that I want to focus on. First of all, I'll develop the technology. Second, I will focus on skill development. Third, I will focus on developing a entrepreneurial ecosystem. Fourth, I will try to get international collaboration and best case studies. So this can be a framework for answer in interview. All right. What are the benefits of this mission? This will basically bring entire new skills in the labor. The mission will act as an engine of growth that will benefit a lot of places, because like I said, it can be implemented, cyber physical systems can be implemented in so many areas. So it will change the way we live. Job opportunities will be enhanced, obviously. New people will be needed to create such systems. As innovation starts, as ecosystem develops, the startup will also be created, and again jobs will be created. So this is the benefit of cyber physical systems. Basically, this is fourth industrial revolution. Now in robotics, let's discuss briefly about robotics process automation. Now in robotics, you know what is a robot. It is a programmed machine, simple, which is designed to do a particular work. Now, what is RPA? RPA is basically a software robot which will do something which humans do on a regular basis. Let me give you an example. There is a very popular story of automation. So, focus on this word, automation. So, there is a very popular story in IT circles of automation. So, what happened was, there was once a person who was very smart, right? And he wanted coffee at regular intervals. So he used to get up from his chair, go to the coffee machine, prepare his coffee, come back, sit. So this would take 5 to 10 minutes. And this person is not that talkative. He is an introvert type person. So he doesn't want to interact with anybody. So just listen to what he did. He hacked the coffee machine, and he wrote a command, right? He wrote a program. He hacked the coffee machine. He wrote a program, and you know what he did? He just used to press enter from, or basically he used to run that program from his computer. He used to wait for a minute, all right, and then go to the coffee machine, take the coffee and come back. That's it. So he didn't have to stand over there, wait for the coffee to be prepared. So he hacked the coffee machine, automated the process, just used to go there and come back. That's it. He didn't used to wait to put cup under the machine, pour cream, sugar, or whatever it is. So this is automation. One more example that I can give you of actual things that I've seen in robotic process automation is, earlier, to get money from a client, you used to get a lot of approval. But now, getting money from the client, international client, has become very easy. I used to work in IT projects. So the way I got that, let's say, the money was very simple. I just sent the invoice to the person whom I was in contact with in the company. He approved it. Then only one another human approval was needed, which was from his boss. That's it. After which everything was automated. Everything. Like I sent an email, that email was approved. The person who was leading the project in India clicked approved. It was sent directly to his boss. He didn't have to send the email. That's automation. Then the boss approved. He also did not send any email. Then that email went to the finance department. Now the finance department had my details with them. So they also just inserted the details and approved the amount. That amount directly came into my account. Getting my point? So all this was very complicated before automation. Every step was controlled by a human. A human had to approve. It used to take 2-3 more days. especially in private company. Forget about government projects. So this is robotic process automation. Basically, you create a software and it will do something which humans are used to doing regularly. All right. Basically, it will replace humans. Getting my point? But this is not something physical robot, like physical robot. This is a software which will be written, but it will do only one work. Okay. What is the effect on jobs? So India is famous for getting things outsourced, right? IT projects, वगैरह. So there is a fear that such projects will not come to India again. But there is a research done by Gartner. In research, it predicts that there will be net gain of jobs due to RPA, largely because of artificial intelligence. Because somebody needs to create those automations, na? Somebody needs to maintain those automations. So jobs will be created, but they will be created for specific things. You will need to learn coding. Your kids, my kids might need to learn coding if they want to survive in this world, in AI world. Of course, hardware is also needed to be manufactured. Hardware robots need to be manufactured. Hardware robots need to be programmed. So who will program them? So a lot of things will be IT based. Now here I would like to share this quote by Bill Gates. He said, the first rule of any technology used in business is that automation applied to an efficient operation will magnify the efficiency. The second is automation applied to inefficient operation will magnify the inefficiency. Getting my point? So it is not like that if you use automation, you will get a better system. No, the system might get bad also if it was a bad system. Getting my point? So understanding this and relating to the job scenario, the robotic process automation can never replace fully humans because we need to maintain the robotic process automation also. So we need more skilled employees. Machine and humans will need to work together to work efficiently. All right. Some examples of robotics: medical nano robot. We have talked about nanobots, so I'll not talk about this here. Karmi bot is there. It was a robot deployed by Kerala government to serve food and medicine to coronavirus patients. So in coronavirus, lot of examples I have taken in my sessions. So such things are quite important. These are live examples. These are good examples which you can quote and impress the examiner. The robot is developed by Asimov Robotics. Now researchers have also produced a new class of antibiotics known as class 2 polyketides. They have used robotics to engineer the bacteria, right? So all these things give us a hope for future, that not just normal things which we worry about job, but robots will be used to save life also. Right? So technology is all about how you use it. Technology in itself is not good or bad. Technology, like fire, is a tool. It depends on the user, it depends on the policy maker, it depends on the government, on how do they utilize the technology that is there. Because lots of technology is going to come up in the next few years, and it's up to us to utilize it in a better way, which will lead to growth and development. All right. So that is all, students, for this lecture. I hope you learned something new. I think this was quite an interesting lecture. We will continue IT lectures for next few lectures, so as to cover a lot of important areas. All right. See you in the next lecture. That is all from me for now. Do revise and see you in the next one. Bye bye. Take care.